Okay, get this. Scientists can now see something called a dark exciton, and it could like totally change how we power the world. Imagine solar panels, but they're so efficient they can power entire cities. Or LEDs that are like way brighter but use almost no energy. That's the kind of future we're talking about. So, what exactly is a dark exciton? Well, picture this. You have some material, and an electron inside it gets hit with some energy. This electron jumps up to a higher energy level, leaving behind, well, kind of a hole. Yeah, this electron-hole pair, it's bound together. But here's the thing, it doesn't emit light, hence the name dark exciton. And because they don't emit light, they've been, well, really difficult to study. Until now. Researchers at the University of Göttingen have developed this, well, it's revolutionary. It's a new technique called Ultrafast Dark-field Momentum Microscopy. It's like this super-powered microscope. And it can not only see these tiny dark excitons, but also track their movements. And in real time. Using this technique, they observe these dark excitons forming in a material made from tungsten diselenide and molybdenum disulfide. Two of the most promising 2D materials for building like the next generation of electronics. And what they found is pretty mind-blowing. First of all, the speed at which these dark excitons form. It's unbelievable. We're talking 55 femtoseconds. That's, hold on, 0.0000000000005 seconds. That's like a million times faster than you can blink. But it's not just about speed. It's about precision, too.
Yeah.
They were able to track these excitons movements with crazy accuracy, down to 480 nanometers. To put that in perspective, a human hair is about 80,000 nanometers wide. So, like, we're talking about observing and tracking things on a ridiculously tiny scale. Now, you might be wondering, why should I care about all this? Why are dark excitons so important, especially when it comes to energy? Well, it all comes down to efficiency. See, these dark excitons are, well, they're especially abundant in these ultra-thin 2D materials. These materials are crazy thin. I'm talking atomically thin, which means they have a ton of surface area for their volume. And that's where dark excitons come in. They form on these surfaces. And they could potentially transfer energy much more efficiently than in bulkier materials. And now that scientists can actually see these dark excitons, they can finally start to understand how to control them and manipulate them. Think of it like cracking a secret code. Once you know the code, you can use it to build something amazing. This is where things get really, really exciting. So Dr. David Schmidt, one of the researchers involved in this whole breakthrough, he's super interested in how this new understanding of dark excitons can be used to like improve the efficiency of solar cells. I mean, just imagine solar panels that can like capture way more energy from the sun. We're talking about a total game changer, but wait, there's more. Dr. Marcel Reutzel, another researcher on the team, he thinks this technique could be used on like a whole bunch of materials, not just for solar cells. Think about it. This could mean like more efficient LEDs or more sensitive sensors. And who even knows what other crazy technologies we haven't even thought of yet. So what does all this mean for you? Well, imagine a future where energy is like abundant and it's sustainable. And it's all thanks to these tiny little dark excitons. It's like we've unlocked this hidden superpower. It's like a superpower of the universe. And this is just the beginning. There's still so much we don't know about dark excitons. What other, secrets are they hiding? What other cool technologies could we unlock as we keep, digging deeper into this exciting field? It's like we've stepped into this whole new world of possibilities, a world where energy is cleaner and more efficient, and it's more accessible to everyone. And it's all because of these tiny, tiny particles that we're, like, just starting to understand. It really makes you wonder, what other mysteries are out there just waiting to be discovered? What other breakthroughs are right around the corner? I don't know about you, but I think it's a pretty exciting time to be alive, especially if you're as fascinated by science and technology as I am. I, for one, can't wait to see what the future holds. And I really hope you'll, join me on this journey of discovery. But for now, man, I'll leave you with this thought. What if dark excitons, hold the key to a truly sustainable future? It's definitely a question worth thinking about, and I'm sure it's one that scientists will be exploring for years and years to come. This research on dark excitons, it's like getting a brand new pair of glasses. All of a sudden we can see everything in it, like a whole new way. And it makes you think about all the amazing progress we've made in technology, right? I mean, computers, smartphones, the internet, it's crazy. And now with this breakthrough in dark exciton research, who knows what incredible new tech is coming next? I mean, we could be talking about solar-powered cars, the kind that never have to be plugged in, or the houses that make more energy than they even use, or maybe even like portable devices that power themselves, just using light from around them. The possibilities, they're like endless. And the best part is this research, it's not just about making our gadgets better and our lives easier. It's about building a better future for the whole planet. By using the power of dark excitons, well, we can stop relying so much on fossil fuels, and we can build a cleaner, healthier world for everyone. And a pretty exciting time to be alive, don't you think? I mean, who knows what the future holds, but one thing's for sure, dark excitons are going to be a big part of it.
So keep those imaginations going, because the world of science is full of surprises, and the future is looking pretty bright. And hey, maybe one of you listening will be the one to make the next big discovery in this field. Well, that's all for today. Thanks for joining me on this journey into the world of dark excitons. Until next time, stay curious and keep exploring.